Welcome back, guys, to Java Space. In the previous video, in the previous lecture, we talked about indicators and health indicators and how we can create our own custom health indicators. In this series, we are going to talk about metrics. It's going to be a long series, but this first video will just be tailored towards just the theory part of it. So we know that metrics are used for, gathering information on your application, and we have seen that metrics can be divided into four types or four categories, and which are gauges, counters, timers, distribution summaries. And we saw that already Spring Actuator comes with default metrics that are implemented for us through auto configuration. Auto configuration, they look at what is in the property files, what is in the class path, some other conditions, all that. But now we also want to create our own custom metrics. So the way to create this custom metrics, actually it is a couple of ways to do it, which we will see when we continue with the series. But the first thing that you would normally do is you will use a MeterRegistry when you are registering your custom metrics. And this MeterRegistry is a bean that is registered for us in the application context. When you add Spring Boot Actuator as a dependency in your project, it will auto-configure MeterRegistry bin for you. And this bin is injectable anywhere in your application. You can actually inject it and use it the way you want. Setter injection, constructor injection or field injection, whatever you want to choose. So this is your custom metrics, together with the default metrics that comes with the Spring Actuator, would be added under the endpoint actuator /actuator/ metrics. So there are ways of gathering metrics. That's why we want to talk about dimensional and hierarchical metrics. So when you have metrics and you want to fetch data or query those metrics, you can use a combination of some filters to do so. For instance, let's say we want to check metrics on web requests that are coming into our application. Normally, you would want to check things like response status, what was the HTTP method, exceptions or errors if they are there, and you want to aggregate all these things. A business requirement could be, give me all successful requests of type GET. And if we say it's successful, we know the status code is 200. So we want to know how many of all the requests that came into our application were successful. Or I could say, I want to know the total number of requests that failed from the region Africa. So this could be one of the business requirements in your company or whatever situation you find yourself in. So all these requirements, there are several ways you can implement them in your filtering. So let's talk about hierarchical metrics. So this one actually follows a naming pattern where we see keys that are separated with key values are separated with a dot. So let's say, for instance, we still want to check metrics on web requests coming into our application. So the example would be, I wanna get all the GET requests that are successful. You can just ignore this status 201. So you would say HTTP in your query .method.get.status.200. Or if you don't really care about the status code, you will just put a wildcard, which means all the status codes are allowed for this particular method. You can also wildcard the method. It's all in your hand. But you can already see that this approach has some problem. First, it's hard to maintain. I mean, it's not flexible. If you have to say http.method.get.status.201, you see, you have to follow a strict order to achieve what you want to, the query that like the business value or the business information you want to derive. And if we were to remove one attribute, or if we were to add, let's say on HTTP method, then we say dot, and then we add a new attribute there, it means our already existing queries will break. So clearly, we see that this is not maintainable, and additional things will break our already existing queries, because you have to follow that strict order separated with dots. So to solve this problem, we want to use dimensional matrix. So with dimensional matrix, instead of following a naming pattern where keys values are separated with a dot, metrics are rather tagged. So this is referred as dimensional matrix. So let's go back to our previous example. Assume you want to check metrics on web requests coming into our application. So instead of using a dot, here we see that we are saying HTTP tag equals to method.get and tag equals to status 200 or 201. And we see here we are saying we can add more things as we wish. We say HTTP tag equals to method colon put method put and tag status, you don't care, or which tag status, and the region where the request is coming from is Africa. And we also have the other one. Here you see we have swapped the order now. You are saying HTTP tag equals status tag status equals 201 and tag method equals to get. So we see now we have swapped the order. It doesn't really matter what comes first, and yet we will still be able to get the business value that we want. So the advantage that we see here is that now this one is maintainable, and we don't have any pattern that we have to follow, or you don't have any order. And then if we were to remove an attribute or to add an attribute, we won't break. If you add a new attribute, you don't really break the query. So if we were to add something, we don't break the existing query. But now if you are to remove, obviously you will have to remove that because it's no longer available for querying, which actually makes sense. But the problem now is adding stuff. So if we add new things, the query breaks. So those are some of the issues that we see with hierarchical matrix that dimensional matrix is actually addressing. So in the next video or next lectures, because this was just theory, we are going to focus on now writing some code. So the way we are going to create matrix in several ways. The first that I will show you is writing matrix in an intrusive way, which means you scatter code, you glitter code. What do I mean by that? You mix your concerns. So you mix your matrix collection code with your business logic, which is a bad coding anyway, because you don't have to mix concern. You have to have separation of concern. Then I will show you how to do it with annotations, and then I will also show you how to do it with some aspects. Then we can look at some other videos. Thank you.